for the second lesson of chapter 18. Again, it's kind of like the first lesson. We're not really going to be doing like formal handwritten notes for this because it's just pure formulas. In lesson 2 here, we're going to look at surface area, and in lesson 3, you're going to do volume. But it's like pure formulas. That's all we do. So here's one thing though that you do got to keep in mind. This is how to make use of your formula packet. Notice these are the only 3 surface area formulas I get, and if you look a little more closely at these surface areas formulas, they are somewhat incomplete. When it comes to doing a 3-dimensional shape for surface area, here's what they would intend for you to do. They would intend for you to do what we call the net. The net is simply if you take a prism like this. Notice if I want to find the surface area of a prism, if you look at your formula packet, none of these 3 show you the surface area of a prism. So how do we find it? So again, this is the intent, is they want you to find the area of all the faces and then add those answers together. So as I look at this prism, I can see that it has 6 rectangular faces, right? So I got a top and a bottom, I have a right and a left, I have a back and a front. There are 6 faces, so what they would have you do is simply find the area of those 6 rectangles and add them together. And for those formulas, those are the old ones that we used in lesson 1. So you would kind of stray from this and you would go back to, not that you don't know how to find the area of a rectangle, but if you weren't sure, right, this is where you would find it. I would say, okay, I'm going to do this 6 times. So I got 6 rectangles for that prism. So I'm going to do this for all 6 faces and add those answers together to get my answer. So this is how to make use of your formula packet. So again, you're not going to find one big formula for a prism, a rectangular prism. It's a matter of just identifying that there are 6 rectangles, and you're going to add those 6 rectangles together. Here's another prism, a triangular prism. And again, for this guy, like, you're not going to find a surface area formula for a triangular prism. What you have to recognize is that I have 5 faces here, and I simply have to come up with the area of each face and add those 2-dimensional shapes together. So I'm taking this 3-dimensional shape, I am breaking it into 2-dimensional shapes so I can find each face individually and then add my answers together. So again, you got a couple rectangles in here, you got a couple triangles in here, so you just simply find the area of those individual pieces just like we did in lesson 1, and then you add all your answers together. You have the formula for the area of a rectangle and the area of a triangle in your formula packet. So that's what they would intend you to do, for you to use your formula packet, break this into 2-dimensional shapes, find each shape individually, and then add your answers together. Here is a pyramid, and again, you're not going to find the surface area of a pyramid, right? This has one base. In this case, it's a square. It could be a rectangle, but in this case, it's a square. So I'm going to find the area of a square. Plus, I have 4 triangular faces. What we would call the lateral area are those 4 triangles, right? A 3-dimensional shape is always made up of a lateral area and the base. So that's what we have. We have the base, which is a rectangle or a square, and then you have the lateral area, which are the 4 triangular faces. And so for those, you're just finding the area of a triangle. So if I wanted to do this one right here, if I wanted to find that area, right, I have 1/2 the base times the height, right? And that's the area of one triangle. Now, one shortcut is to recognize that these 4 triangles are the same. If this is a square, then the 4 lateral faces, the 4 triangles, are the same. So if I find one of those, I can just multiply it times 4. So that would work if the base is a square. But anyway, one more thing to point out. You're going to notice these 3 are in your formula packet, but these are the ones that I was referring to that are kind of incomplete. If you look at those formulas, so that's these 3 right here, notice this says, so this is a cylinder, and it just refers to the curved surface of a cylinder. Well, if you look at a cylinder, here's a cylinder, right? The curved surface is this big part of it, right? So if you eliminate this circle and eliminate this circle, then you're left with what we call the curved surface. And that's all they're telling you within that formula. So what we have to recognize is if I want the total surface area, I have to do the curved surface plus this circle plus this circle. So remember, three-dimensional shapes are always made up of bases and a lateral area. So what they give you in the formula packet is just the lateral area. That's what they call the curved surface, or we would probably have seen that as the lateral area. So I get the lateral area, which is all of this, plus I have to recognize that I also have to add in 2 circles to get the total surface area. So again, they do give you the formula for this, but it's in pieces. So I would have to look at this and say, okay, here is the curved surface, but I also have 2 circle bases to add into this. So that's when I'd have to go back to this and say, okay, I'm going to do the curved surface plus I also have to add in 2 of these. So it's 2 pi r squared plus the curved surface, which is 2 pi r h. So all together it's going to be 2 pi r squared plus 2 pi r h. That's the total surface area. So the same is true when you get to like a cone. Notice this is just the curved surface or the lateral area. It does not include the circular base. And so to this, I would also have to add in 1 pi r squared. So they're giving me pi rl, which is just this part of it, just what they call the curved surface, plus I have to add in the pi r squared for the base. And so this is actually a good representation of the total surface area. So your book just gives you this part of the formula right here, the pi rl, that's the curved surface, that's this, plus we have to add in the base, which is a circle, so pi r squared. So do keep that in mind. The sphere is all there. That one's right. There is no base to a sphere, so that is the total surface area for a sphere. But again, when it comes to these two, you also have to add in the bases to this on your own in order to get the total surface area. So again, that's the idea for working with these three-dimensional surface areas, is identifying the individual parts and adding all the parts together.